All right, guys. So in this first section of Unit 7, we're going to be talking about polyhedrons and the volume for rectangular prisms. And really what that's going to help us to do is start to talk about volumes for other figures in later sections. Let's start with the definition of a polyhedron. So a polyhedron is a 3D object which is created using polygons. So if you remember polygons, we talked about those a lot last unit in Unit 6. We're going to now look at polyhedrons, which is basically a 3D object where you put multiple polygons together. One special type of polyhedron we're going to focus on today is what's called a prism. So a prism is a polyhedron with two parallel congruent faces. And so if you look at this example that I've got here for us, which would be a triangular prism, and we'll talk about the different types in just a moment. But when you look at this, the two congruent bases are these two triangles, which I'm shading in for us in red. So that would be why this is a triangular prism, is that the two bases are triangles. In fact, those two bases, let's just name those real quick, would be triangles ABC and triangle DEF. So again, those would be our bases. So lateral edges are going to be any edge that runs between the two bases. So for example, this line segment AD would be considered a lateral edge. So you can probably see that there's going to be two more. There is CF, and then there's also BE. All right. Next up, for the height of our polygon, it has to be one of our lateral edges which is perpendicular to our base. In this case, let's just use AD. You could have also used CF or BE, but we'll just say AD is our height. And again, with height, you might make a note to yourself that the height must be perpendicular to the base. So remember, this symbol is the symbol for perpendicular. All right. So similar to lateral edges, we also have what are called lateral faces. Lateral faces are basically the shapes or the polygons which connect your bases. So one of those, which I'll shade in and then I'll kind of get rid of, but one of those is this face of ACDF. I'm going to go ahead and write that out here. So ACDF would be one lateral edge. So you can probably see that there's going to be two more, which are this one over here, which is BCFE. And then finally, we've got a third lateral face, which is ABED. And then let me go back and fix that first one. It should have been in order ACFD. So let me get those two last vertices in the correct order. All right, and then the last part of vocab that we're going to talk about is what's called a base edge. So these are the edges for our bases. Since we have triangles, that means that there's going to be three base edges apiece. So that would be the edges like AB, BC, and CA. So there would be the three for our base at the bottom of this prism. And then we've also got the three for the top, which are DE, EF, and FD. All right, so let's do some practice with this vocab. So given the rectangular prism now, with BCFE as one of its bases, you notice that the yellow highlighted part at the bottom here is going to be our base. We're going to try to use each of these values only once. So let's take a look. For base edge, remember a base edge is any edge that would be on the base of our prism. Now, there are two bases that we can look at. There's this base at the bottom, there's also this base at the top. Now remember, to be a base edge, we have to have a line segment. So there are two line segments that we can currently pick from. We can either pick HF or we can pick AD. But the problem is HF is not a base edge. HF is one of our lateral edges. So looking at AD instead, AD is in fact an edge which is on our base. So that's going to be the one that we are going to pick. So the answer for number 1, AD, and that's the letter C. So let me just use the letter for the multiple choice that we're using. So that would be C. Which actually, that helps us out with number 2, because there's only, well, let's see, I guess not lateral edge, but lateral face. So let me kind of take that back. So lateral face, we're looking at any of the faces that would connect our two bases. So GHEF would be a lateral face. However, it's not an option for us to pick from. But if you look at what's shaded right here, which is HDCF, that is going to be a lateral face. That's the rectangle, HDCF. That is option E. Next, we're going to look for a base. There were two bases for us to look at. There's the base at the bottom, which is BCEF. That's not an option for us. There's also this base at the top, which is ADGH. And that is, in fact, one of our bases and one of our options. That would be option letter A. For number 4, for a vertex, you are looking for just any point that is part of your prism. And so that should make it pretty easy. There's only one option, which is a point. It tells us option letter D is point B. So that would be this point right here, which is in fact a point on our prism. So that would be a vertex. So letter D would be the number 4. And then finally, for lateral edge or height, we only have one option left, which is HF. We did talk about this before, how HF is in fact a lateral edge. It would also be then considered a height. So that would be option letter B, and that would be our last option. All right, so let's talk about how you can name prisms by their shape. And the way we do that is we name them by their base. So looking at these prisms for each of the problems in this box, let's kind of take a look at each of them. So for our base on this first one, our base is going to be this piece right here. And if you look at what shape that is, you might be tempted to want to say that's a square, but I don't think that we'd be able to gather that information just from looking at it. Obviously, we do have our height right here as well. And I think actually for this one, let's kind of think about it as being more of a rectangular shape right in here. So actually our base would be kind of this piece right here as opposed to the part that was shaded, in which case our base is certainly rectangular. And even if we chose to switch our base around, still would be most likely rectangular. Hard to tell, it would be a square. So that we're going to consider this to be a rectangular prism. The next one's quite a bit easier. We've actually already talked about this. That was kind of what we used as our first example. Our two parallel bases quite clearly are triangles. So this would be a triangular prism. In addition to that, obviously, our height is going to be any of our lateral edges. So our height would be this right here. All right. And then for this last one, our base, a little bit different shape than we've seen on our last few examples. But looking at that, it definitely has 6 sides. Remember, 6 sides is a hexagon. So we call this a hexagonal prism. And then our height would be any of those lines connecting your two bases, so your height would be right here. All right, so let's do that for a few more examples. We're going to shade our base like we did in that box above, and then we will highlight the height and properly name each of these prisms. So for this first one, looking for your two parallel bases, here would be one base, and here would be your second base. Pretty clearly, those are triangles, so this would be a triangular prism. I also did ask us to highlight our height, so we'll just pick one of those lateral edges. If you want to draw in the right angle symbol to show that it's a right angle, you can, and there would be our height. This next one actually already has the right angle drawn in there for us. So looking at our two bases, we've got our one base right here, our second base right here, and then our height right here. Looking at our two bases to see what type of shape they are a quadrilateral, but let's be a little bit more specific here. In this case, because two of the sides are parallel with one another, we can actually say that this is a trapezoidal prism. And I'm just going to switch the color so we can make that a little different. Perfect. Okay, let's take a look at one last example here. We've got our two parallel bases, which I will shade in for us first. And then we've got our height between those two. So this part right here would be our height. Looking at the two bases that we shaded in, they are both 8-sided. 8-sided would be an octagon, so this would be an octagonal prism. So again, when we name those, we really just put AL for the most part after it. So hexagonal, trapezoidal, octagonal, and so on when we're naming those in order to describe the type of prism. Okay, now let's go ahead and talk about the volume for a prism. So we want to find the volume for a prism. What we're going to do is we're going to take the area of our base and multiply by the height. So kind of a similar idea, kind of a familiar idea if you really think about it. But what that means is now that we're in 3 dimensions, we're going to be multiplying 3 things together instead of 2. Now the base, notice in this case, is the length and the width. And so another way that you could write your volume formula would be to take your length multiplied by your width multiplied by your height, which again should kind of make sense. In 2 dimensions, you're multiplying 2 things to find area. In 3 dimensions, you're multiplying 3 things to find volume. All right, so let's go ahead and find the volume for each of these prisms that I've got for us here below. So I'm going to probably use the second formula instead of the first, but it's really kind of up to you how you'd like to do it. It doesn't matter really what you make what. I'm going to go ahead and have my length be 9, my width be 17, and my height be 24. So for our volume for this rectangular prism, again, we're taking length multiplied by width multiplied by height. So that's 9 multiplied by 17 multiplied by 24. And here's where we go ahead and grab a calculator and multiply those together. So 9 multiplied by 17 multiplied by 24 is 3,672. Now let's go ahead and include our label. It was centimeters for each of our edges, so that would be centimeters, but not centimeters squared. Centimeters squared was to the power of 2 because we were multiplying 2 things together. Now that we're multiplying 3 things together, that's going to be centimeters cubed, or centimeters with an exponent of 3. All right, let's take a look at 2 more examples of this, and then I think we'll be good for today. So for this next example, we're going to let our length be 10, our width be 14, and our height be 4.5. So our volume would be equal to multiplying those together. So that would be 10 multiplied by 14 multiplied by 4.5. And when we multiply those together, feel free to use a calculator to do that. We're going to come up with 630. And then don't forget your label, which is inches. And it's being taken to the power of 3, so inches cubed. All right, one last example. Let's go ahead and take a look at it here. So we've got, once again, a rectangular prism, or a rectangular prism, rather. And let's go ahead and label our sides. So let's let our length be 8, our width be 12, and our height be 39. So multiplying those together to find our volume, we're going to take 8 multiplied by 12 multiplied by 39. And using a calculator to help us, we can multiply those together. It's going to be 3,744. And make sure to include your label, which is feet cubed. All right, guys, that's all I've got for us today. In the next section, we'll talk a little bit more about volume. We'll do it for some other types of prisms, such as triangular prisms, trapezoidal prisms, and so on. And then we'll also start to talk about cylinders. Until next time, have a great rest of your day.